guys, happy Tuesday night. Alright, so video number 2 of 2020 for pre-algebra, and we're going to be looking at experimental probability. So go ahead and write this down with me. Experimental probability. And there are two kinds. The first kind is called simple. Simple events is just one event. And then complex. More than one event. Okay? So, let's write a few notes there on the top here. Let me get a color that you can see. Simple is just one event. And when I say event, I'll show you what that means. Complex is more than one event. Okay, so let's get started. So simple, I'm going to abbreviate this. Simple experimental probability. Okay, that saves us a little time right there, right? Ex prob. Alright, simple experimental probability. This is your basic probability, like what we did today in class, where we said a bag holds 6 tiles. Okay, so a bag holds 6 tiles. Here's an example. Alright. There are 4 red and 2 blue. Okay, so there's 6 tiles total. What is the probability to draw a blue tile? Alright, so first of all, we go back to our probability notes. It's really easy, but we have to make a ratio. So we're going to go back to our probability notes. The definition of probability is the extent to which an event is likely to occur measured by a ratio of favorable causes to the total number of cases. Not causes, cases. So favorable means the answer that they're asking you about. So the blue tiles would be the favorable ones. How many blue ones are there? There's 2. That's your favorable. Alright, and then over total. What was the total? There's 6 tiles. So you had a 2 out of 6 chance of drawing a blue tile. Okay? So we can simplify this down to 1 out of what? Yes, I hope you said 3. Okay? 1 out of 3. You have a 1 out of 3 chances, a 1/3 chance of drawing a blue tile. So 1/3 is the same as 33.3 repeating percent. So is this what would we call this? We call this certain, likely, likely as not, unlikely, or impossible. Well, it's less than 50%, so we're going to say it's an unlikely. But remember, we didn't actually draw any tiles. So what we did right here, this is not experimental probability, because we didn't actually have 4 tiles and then draw them out 6 times. What did we just assumed based on 4 versus 2. We didn't even do the experiment. So this couldn't be experimental probability. This is actually an example of what? This is theoretical. And I wanted to show you that first so that you could see the difference between experimental and theoretical. Now, if I had some papers, some tiles here, and we had 4, I have a red, and I have another red. How many reds do we have? 4. Okay, and a red. Okay, and one more red. Okay, 4 reds and 2 blues. Blue, blue. Okay, so now I'm really doing the experiment here, right? Okay, and if I put these in a bag, oops, I just ripped my paper. I put these 4 reds and 2 blues into a bag, okay, and I randomly did, let's go back to our notes so we can look at experimental probability, right here, experimental probability, the number of times an event occurs divided by the total number of trials. So it's not going to be the total number of outcomes this time because it's not going to be over 6. I'm not going to draw 6 of them. All right, I'm not going to do 6 drawings. I'm only going to do 3. Okay, so okay, so example 2, we're going to do. It's going to be experimental. So we're going to do favorable over number of draws, okay? All right, so I'm going to draw, the first time I'm going to draw randomly. I know you can't see me, but I'm randomly drawing. I drew a red, okay? So first one I drew was red. Then I'm going to draw again, and I drew another red, okay? So I drew another red, totally random, okay? And then the last one I'm going to draw, let's see, is a blue. Okay, so we did get a blue in there. So I had 3 draws. Total number of draws was 3. How many were favorable? Well, I was looking for blue tiles. Blue tiles. So only 1 out of the 3 were blue. 1 was blue. So it just so happens here that my theoretical and my experimental probability was the same, but it's not always the case. What if that last one I had drawn was red? Then it would be a 0 out of 3, which is a 0% probability, right? So it just so happened that they were the same. I just decided to do 3 draws instead of 6 or 4. I could have done 4 draws, could have done 5 draws, could have done 2 draws. But they did happen to be the same, but that's not always the case. I wanted you to see the difference between theoretical and experimental. Now, let's go on to simple versus complex. Simple versus complex. So let's do some complex probability. We're going to be dealing with this in class on Thursday. So you're not going to have a Wednesday video. So if you can bear with me here, there's no video tomorrow. Probability? No, that's not it. There's no R there. Probability. Okay, complex probability. Okay, complex probability is when there's more than one event. So, and we just did one thing here. We just had tiles, and we wanted to look for one blue tile. All we were looking for was the blue tiles, okay? So, that was just one event. This is greater than one event. Greater than one event. Okay. So, let's see here. Complex probability. Let's look for an example here. Flipping, let's see. Flipping heads on a coin and rolling a 5 on a normal die. Okay, so this is all theoretical. Let's just do theoretical first. We're not actually going to do the experiment. Theoretical. Theoretical. Oh man, I'm going to start over. Theoretical. Okay, theoretical. Alright, this is just a theoretical one. Our example is this. Flipping heads on coin and rolling a 5. Okay, on a die. Alright, so these are 2 different events. This is event number 1, flipping heads on a coin. We can figure out the probability of that theoretically. And event number 2. Alright, you see how there's 2 events here? There's more than one event. So let me show you how you figure out the probability of 2 events happening at one time. Alright, you get the first one. So what's the probability you would flip heads on a coin in one try? All right. Well, it's a 50% chance. So it's a 1/2 probability, right? 50% chance that it's either heads or tails. Head or tails. 50% chance you would flip heads on a coin. And then rolling a 5 on a die. Alright, so rolling 5 on a die, well, a 5 is only on a die once, and there are 6 numbers on the die, 6 sides, 6 different numbers. So you have a 1 in 6 chance of getting a 5 on a die. Alright, so that's where we got the 1 in 6 from. It's from event number 2. This is from event number 1. Alright, so now...
Good morning, teachers. If you have gym duty, you need to report to the gym immediately. If you have gym duty today, please report to the gym immediately. Thank you.
The announcements are lighting it up. Alright, so what we do here is we actually multiply. We multiply. We multiply the two fractions, the two ratios of probabilities. So you have a 1 times 1 equals 1. 2 times top times top, bottom times bottom, remember that. And 2 times 6 equals 12. So the probability of both of these things happening is 1 out of 12. For both happening. Flipping heads and rolling a 5 on a die. Okay, do you see that? This is how we do complex probability. More than one event. We had 2 events. Let's do one more. These are all going to be theoretical tonight. We're not going to actually do these experiments right now. Okay, but you know that they could be different if we actually tried them out. Okay, so we have another theoretical. Alright. Example 2. 60% free throw shooter makes 3 free throws in a row. A little basketball one for you. So we have 2 events here. Actually, we have 3 events. So he's shooting 3 free throws. And he's a 60% free throw shooter. So let me show you how this works. We're going to put this in a decimal form. So that's 0.60. Easier to multiply when we have things in decimal form. And he's shooting 3 free throws. So that's actually 3 events. 1 shot, 2 shots, and then 3 shots. Okay? So he has a 60% average, so we're going to multiply 0.60, that's 1 shot, 0.60, that's 2 shots, 0.60, that's 3 shots. We're going to multiply all of those together. 0.6 times 0.6 times 0.6. Well, if you do that, I'm going to save you some time. I'm going to get out my calculator. But you could do 0.6 times 0.6. That's going to give you 3.6. Okay. Oh, no, sorry. It's 0.36. 0.36. I knew that did not sound right. 0.36. And then times 0.6 again is going to do 0.216. So that equals 0.216. He has a 0.216 chance. So if we were to convert that into percent, you just move the decimal over 2 places, and it's 21.6% chance. So 21.6% chance of making the free throws. Is 21.6, is that likely, unlikely, likely is not? What is that? Well, if we look back at our term from last night, if it's less than 50%, it's an unlikely chance. So this is pretty unlikely. Even though he's a 60% free throw shooter, which is not terrible, it's unlikely that he would make 3 in a row. Okay? Alright, so we'll be doing some more problems like this in your warm-ups and in class, but I just wanted to kind of show you the difference between theoretical and experimental probability at the top here, and then the difference between simple and complex probability. Have a good night.